All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. I am so very excited to have this conversation today with two very, very smart people about AI and machine learning and security. But before we get things kicked off, I do have a few housekeeping items I need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience throughout the webinar. So if you have a question for either of our speakers at any time during the presentation, please don't wait. Just get your question right on in, and we'll include it during our conversation. Want to emphasize that we want to make it as interactive as possible. So we won't have a formal question and answer period near the end of today's webinar. We will be taking questions throughout. So please do not wait to get your questions in if you have one. We also have a very interactive chat feature, so we also welcome your comments and suggestions in that chat box. Please don't hesitate there either. Go ahead and if you've got a comment that you want to include in the conversation, please send it on over, and I'll be keeping an eye on that chat, and hopefully we can get your comments included in our conversation. And finally, two more things. First of all, we do have a great handout that I want to share with you. It's an infographic that we've created on AI and machine learning and cybersecurity. And I welcome you to click on that link and download it at your convenience. And then finally, we are doing a drawing at the end of the webinar for 4 $25 Amazon gift cards. So please stick around. Hopefully you will be one of our 4 lucky winners. All right, with that, let's go ahead and kick off the webinar, which is AI and machine learning in security. Our speakers today are Christopher Doer, who is the lead cognitive researcher at AppScan, and Julian Miller, who is the CTO of Azaco. Sorry, I got it. Yay. All right. So, gentlemen, thank you both for joining me today. And I want to give both of you guys, first of all, 2 very large thumbs up for joining me today on this webinar. But I want to give both of you a chance to introduce yourself to the audience, tell us a little bit about your company and really where you guys fit into the cybersecurity space at large. So Christopher, why don't we go ahead and start with you, and then Julian, we'll hear from you. And I'm going to take away this title slide so we have more real estate on the page.
Yeah, sure. Christopher, well, Chris Doer, I work with HCL AppScan. It's one of those tools that kind of goes after application flaws that you might have introduced into your code as we do, write code normally. And it tries to keep in mind some of the things that, in my space anyway, it's static analysis that I work on, but we also do dynamic analysis. We do interactive analysis, which is, DAS, SAS, and IaaS. So pretty much everything that you need to worry about in the software coding perspective. A lot of people think about, security and machine learning, and they think network layer. But honestly, if you have a whole world open in your code, it's not going to matter how good your firewall is or how good your web application firewall might be, or your, wonderful SIM that you might have plugged in. You need to harden your code so that people bad actors can't exploit those holes that you might have. That's what we try to present to you using the tool that we support. In my world, I started on this tool about 10 years ago, and I learned pretty quickly the most important part of the tool wasn't the engine, it wasn't the presentation or the findings even, it was the security knowledge, or what we call markup or rules, the stuff that we go after, the things that we care about. So that was ultimately where my security research and learning how to be the white hat hacker, if you will, or trying to fight the bad guys and trying to find ways to stop them from doing the nonsense that they do. And that's kind of where my expertise started. So we kind of naturally progressed into adding machine learning into the components of that whole world that made the most sense. I mean, ultimately, once you've built the engine, it kind of does what it does. It uses the information you provide it, which in our case is, the rules or the security information, and tries to build up this wonderful map in memory of the data flow. And it presents to you these findings, which are very valid data flows, but may not have the security connotation that you mostly care about, something we call actionable versus uninteresting, for lack of a better expression. We decided to take our machine learning approach and try to sort of trim that list down from this giant pile of stuff to a much, much smaller list that's a little bit more consumable using machine learning, using the patterns that machine learning is really good at doing, and saying, we've got all of these findings that we've classified. Now take all of these findings that we haven't classified, and can you guess if they're actionable or uninteresting, or what we would call noise? Even though people call it noise, it's not really noise. It's data flow that doesn't have the most important security connotation.
Right.
A wonderful example might be, say, I don't know, stream read to a stream write. What are you going to do with the binary data in between? That's really what we call an intermediate trace or an intermediate node. You kind of have to figure out what wrote the thing that is reading from the stream. Usually it's a file, or perhaps even a socket read, which God help us all if you do that and you don't do any sanitization at all. But then it goes somewhere else, and it might go to a file or a database. Well, that's still just a kind of a couched possibility. It's not really an attack yet. When you read that file or do something with the stuff that's there, that's where you really need to worry about what this stuff is. And those are the areas we really want to focus on. So interesting or actionable versus not actionable. And we use the machine to try to help us figure that out. I mean, we had such success with it. We decided to maybe just see if it could work to build up the security information, or those rules I was talking about. Can the machine guess whether or not this particular API that we've never seen before is a source of bad data, or if it's an exit point, or a place where we go outside of your user code and into, say, a database or the wire or a file system or whatever. And it turns out the machine can do that too. So not only do we save time trimming down the findings, we save development time trying to figure out what the security information is. And to put it into some perspective of the time savings, it takes about 1 to 10 minutes per finding to figure out if it's interesting, if it's something you care about or want to look at. For someone like me that's been doing it for years, it might take seconds. But for somebody who's never done this before, it could take 10 minutes, just chasing down all of the different paths and saying, well, this doesn't look like it's something I need to worry about, or this is something I really, really need to worry about. And we can take that and condense it down to nanoseconds per finding. You can imagine the amount of time you buy just applying machine learning to what is ultimately a very simple problem. Is this interesting or not? It's a simple classification. It's yes, no, 1, 0, whatever you want to call it. It's super easy. And then you do the same thing with API markup, and it's just mind-blowingly time savings. I mean, it's 1 to 10 minutes per markup. 300,000, APIs in Java alone. You can imagine the time savings there. It's just insanity. Yeah. And we can do it on the fly, so it's pretty cool.
That's cool. Yeah.
We apply it.
I love that. That sounds like awesome technology and a great use of AI and machine learning. So thanks for letting us know about that technology, Chris. Julian, tell us a little bit about yourself and your company and where you guys kind of fit into the cybersecurity conversation.
Sure. So I'm Julien Muller, and I'm a CTO of a company called Ezaco. We are a startup specialized in time series. As a background, I've been working in the AI field and machine learning for the last 20 years. I've seen it evolve really fast, and we've seen the neuronal networks and deep learning come into the field. And I decided to specialize in time series because I realized that most of the data in the actual world is about time series. And specifically in cybersecurity, you can see that time series is really the center of at least monitoring. And for instance, that's where InfluxDB is filling a huge gaps, which is how to store the time series. But storing time series is not enough, in fact, because you don't just want a bunch of data and just be able to query it. You need to get value out of it. So I realized there was a lake for software, and we developed a machine learning software that helps data scientists build actual models to actually do something with the time series. And in fact, cybersecurity came naturally to us because customers came to us saying, hey, I have this kind of data. Can I use it for cyber threats? And in fact, when you're doing time series analytics, you can learn what is normal behavior. So you can actually see, as Christopher said, just the tiny information that is very interesting instead of seeing a bunch of data coming from everywhere from day-to-day behavior.
I just love all this finding out about different ways that cybersecurity is being approached by organizations. So Two great technologies there. That's really great stuff, and it's really great to kind of help frame our conversation about AI and ML in cybersecurity. And one of the things that I want to do is to kind of kick off the conversation, just kind of lay the groundwork on where we are today with AI and ML and cybersecurity, and really why it is such an important part of the cybersecurity conversation. I mean, we've been hearing about artificial intelligence pretty much for every industry these days. There is some way, shape, or form that AI is helping industries, all manner of industries. But in cybersecurity, especially, we can all benefit from what AI and ML can bring to the security table. So, but let's delve into some of the reasons why cybersecurity is benefiting from these technologies. And obviously, we've been dealing with an almost daily exponential increase in cybersecurity threats. And we keep hearing about the ransomware, the number of ransomware incidents that are up, data breaches that are ongoing. And there does not seem to be a way that organizations are effectively mitigating these security threats. So, it stands to reason that AI can help organizations in some way, help at least reduce their threat vectors, their footprints, whatever they can do, and we'll get into that in a little bit. But also one thing that we have been hearing a lot about in ways that AI can help is in addressing a cybersecurity skills gap, or just straight up shortage of personnel. And I'm going to be a little contrarian here, and then Chris is going to yell at me. I can tell already, but I use the term either real or perceived skills gap and skills shortage. But apparently I am way off base by saying that, right?
No, there's a massive skill shortage. It's not perceived. It's just ridiculously real. There's so many gaps, so many open positions just to build the tool, never mind use the tool in business worlds effectively and correctly. There's a number of folks I've talked to that are what I would call superstars or all-stars that can use these tools to very good effect, but you could count them on the fingers of one hand, the people that I've talked to. And most folks, they just don't have the expertise. And it's no mark against them. This is not easy stuff to understand. There's a lot of information you need to kind of pull together and put in front of yourself in your brain before you can even make sense of a lot of the stuff that's coming out of these things. Mm-hmm. So it's not, the old jack of all trades, master of none. You really need to be a jack of all trades in the application security world. I'm sure the same holds true for what Julian does with his software. It's just not easy stuff. I mean, coding is coding. That makes sense. Building a system that, talks from one to the other, that makes sense. Figuring out how to do it in a secure manner, whoa, that's not so easy.
Do you think a lot of that comes from the complexity of IT these days? Because we are dealing with hybrid in IT environments, multi-cloud, just so many different systems that are being connected these days. And now we're talking about edge computing in the mix. And it seems like there's a whole lot out there that IT teams are being tasked with dealing with on a regular basis, and security is obviously part of that.
Yeah, I think it's all of the above, and then some and a little bit more. There's just so many different things. Once you start building a company from scratch, is security the first thing you think about? Probably not. Most companies are worried about getting version 1 out the door so they can start making money. After that, retrofitting security on your firewalls and your code base and making sure the right people have access to the right stuff. Practicing principle of least privilege just in your own environment, never mind in your source code itself. It's a tremendous leap to go from I built a car that goes forward to I built a car that won't explode. It's just a tremendous leap. Look how long it took us to do that with actual cars. This is just not easy. In supply chain problems, did I get a third party, jar that's no good anymore? Or does that third party jar have any issues in it? Or, whatever it is you happen to use. There's so many different facets and so many different places that you could easily get 100% right in 5 of them. And that one that you didn't do, the one that you forgot about, or the one that you didn't know about is the one that ends up biting you. It's insanity out there today. Defense in depth, we say, and zero trust environment, we say an awful lot. And really, if you use that mentality, it's pretty clear what you need to do. It's just changing your perception from I trust the people that work for me and I trust the environment that they work in to I trust nothing. And you'll see pretty quickly what it is you need to address and where it is you need to go after. And you can prioritize it and get it done. But one way or the other, you're going to have to figure it out, because I can guarantee you, if you have stuff that's important enough to go after, someone's going to go after it.
Yeah.
It's only a matter of time until you hit that.
Yeah. I think there's another interesting point regarding attacks and AI, which is really the negative part of AI. So the first one, which is quite obvious, is that the attacks didn't wait for us to use AI. So there has been studies that demonstrate that you can break an AI quite easily. So they could use it as a bridge. And that's really a reason why security people must learn AI and be part of the AI development process, because if they're not, there are going to be huge breaches. So it has been actually demonstrated you could hide a virus into a trained neural network. So this has to be addressed. Also, negligence can help attacks. And this is true for all the fields, but specifically in AI, since it's quite new. For instance, automated car could be hacked very easily just by adding some stickers on road signs.
That's pretty
really?
This is
the old or one equal one attack.
Yeah, so if you really understand how it works, you could just add stickers on the road signs, and the cars are not able to understand the signs anymore. Very small stickers, you could not even see it visually. But the AI doesn't work the same way we do. This is really why I think AI has to be understood by the cyber people.
That's really interesting.
And
finding somebody who knows both is just, oh my goodness. It's hard to find ML people. It's hard to find security people. Finding one person that does both of them. Whew,
yeah, and that's also the reason why we must use AI in cybersecurity, because we won't be able to fight otherwise. So that's why I can't agree with saying that AI is going to take jobs from cybersecurity experts. That's the exact opposite right now, I think.
Yeah, I think you're going to find that the jobs that are available are the jobs that you need a human brain for, which is kind of what we want. We don't want to keep looking through giant lists of nonsense saying noise. No, you want to be working about the stuff that the machine hasn't gone after yet. And there's plenty of work out there for people.
Oh yeah. Well, we were talking before the webinar started, and Julian told us, he's French Riviera, and I've got, very jealous immediately. But you said that the reason why you moved there was because that was where you were able to find folks to work for your company. Because if you work in the city, Paris or wherever, they were all getting snapped up by the larger companies.
Yeah, there's definitely a huge shortage in expertise in machine learning, in cybersecurity. You can see that university schools, they started to add more and more classes about that, but it just started. We're going to have these very expert people within 5 or 10 years. And up to now, well, we're really relying on a very small amount of people, and these people get the jobs they want where they want it. So there are some places where actually the schools made the job earlier, and they helped increase the knowledge of the community. And I think that's great opportunities for companies.
That's good to hear. But until we reach that kind of critical mass where we do have a number of cybersecurity professionals coming out of school, I think we're going to see some tough times ahead in the cybersecurity sector, as far as being able to fill all those positions that are currently a lot of organizations are experiencing. I did pose a question to the audience whether they did believe that there really was a cybersecurity skills or people gap, and Christopher did respond saying, for sure, security is ever changing, and to stay on top of all the intricacies between clouds, on-prem, and everything in between can be mind-boggling. So I guess I am sadly mistaken if I think it's a perceived lack. So it's But we have gotten a couple of questions in so far. We haven't even really gotten into the topic, but this is great stuff. So Mike is asking, my understanding of AI is that labeled data is used to train a model to detect known patterns. Isn't the problem with AI in security that this will not be labeled data for new attacks? Isn't an antivirus essentially pattern matching of known threats? And isn't there breakdown lack of knowledge of new attacks?
Depends on how you label the data or the data itself, how you describe the data. There's ways around that problem in a variety of areas, especially with what we do, and I'm sure with what Julian does. Otherwise, why build it at all, right? If you have to have this hard-coded list of things and it can only ever figure out what that hard-coded list of things is, well, that's not machine learning. That's an algorithm. That's, predicated computation. That's not what we're talking about here. What we're talking about is teaching the machine a pattern or a heuristic or a feeling, if you will, of what this thing represents, as opposed to, well, it has to come from here, go through this, and go to here. That's interesting, and only that is interesting. That's not how it works at all. You describe the data. And the simpler the problem, in my experience anyway, that you're trying to describe, the easier it is to gather that data and have it be a little bit more globally applicable, as opposed to trying to, make code that writes itself from something you say, which is, if you can do that, I mean, all of us are out of a job. So woohoo! And you write secure code, it's the holy grail of software coding.
Right.
We're very far from there. I mean, Skynet is not tomorrow. I don't think we have to worry about that. But we are building a bunch of hammers. We're building a bunch of screwdrivers. We're building a bunch of more complex machinery, such as, doing data lake stuff and time space or time sequencing that he mentioned earlier, which is a little bit more complex, and in neural nets and DeepMind and all that nonsense. It's a much more complex hammer, but ultimately it's a tool. It's a tool we're using to try to minimize our involvement. And by our, I mean people. We need to save us time so that we're focused on the stuff that we need to focus on that the machine can't figure out. So even if that's the case where, there's this new attack that we've never seen before, well, one would suppose that if you built the model right, it's going to spit that out to the top, and you can look at it and say, well, this is a new attack. Oh no, I need to worry about it. And we can update the model to say, now consider this also. So there's a variety of ways you can attack that particular problem and kind of work around it and move past it. It's not as big of a stopgap or a blocker, if you will, that folks tend to think about when they talk about machine learning. It's just not.
Yeah, as Christopher said, I really think we need to build the tools. If you take machine learning in general, the biggest field is supervised machine learning, which is you learn on cats and dogs pictures, and then you have to find the cat on the picture. And this applies really well for automated cars, and most of the fields in machine learning. But if you're working on time series and specifically in cybersecurity, it doesn't help at all. I mean, if we know the thread, we just need a rule and that's it. So what we need to do is unsupervised machine learning. Bad news, it's really hard to have results, and there's less people knowing this field. So, which is you learn on some data and you have to find out new patterns. What's happening that never happened before? Once you got that, as Christopher said, you can just label the data, and then you have much easier algorithms to apply, and you're searching for a specific pattern. When a vulnerability is known, you can just record the pattern of this vulnerability and search for it. That's not easy, but that's much easier than finding new behaviors or, as Christopher said, new issues in the software.
Okay. All right, great. So it's it sounds like we're still, oh God, this camera. It sounds like we're still very much kind of in the, the early days of what AI and ML can actually do as far as maybe proactive security. It's still kind of more reactive based on what's happened in the past. Am I right?
Yeah. As far as I'm concerned, that's what makes this whole world of security and AI and ML and all that so exciting. We haven't even started. I mean, we've got these silly little tools that do what we need them to do, but really it's just a tool. We don't have an architect yet. We don't have a machine learning architect that can go in there and make these choices. The unsupervised learning that he spoke of, very, very hard to do, very hard to find the expertise. As you can imagine, if you don't teach the machine anything, how do you expect it to make any sense out of it? there's certainly ways that you can make inferences and such like from this unsupervised world, but really that is, the boop, tippity top. And to get there, we need to get through these other steps where we really understand the problem space that we're worried about. And we've built enough hammers, we've built enough, shovels, we've built enough screwdrivers, and we're ready to start building the house. So it's a super exciting field to be in at the moment.
Yeah, well, and it, as I told you guys at the beginning of the webinar, we can take this conversation in any number of ways, and that's the beauty of this topic. But Tom actually just sent in a comment that I think is really compelling and would be a great one for us to address. Where does the AI initially learn, and how long does it take to learn? Are there significant false positives when initially used? You're right, the Skynet is a long way off. HAL is a myth in machine learning. Everyone's environment is different. So, because of just the breadth of AI and ML in cybersecurity, I think that's the reason why so many organizations are still pulling their hair out when it comes to it, because they just don't know how to start. But and there's also a lot of a lack of understanding about the technology. I mean, Tom's questions are all very, very valid for an organization that really is thinking about it, but really doesn't know how to start. So, Julian, I want to ask you to address this first, because it seems like there is this kind of fundamental lack of understanding about how everyday organizations, maybe folks that don't have an AI person or even a cybersecurity team, and they're kind of doing it all themselves. How can they get this information? And maybe you can address some of these basic questions that Tom has in his comment.
Maybe I'm going to try to present a very simple example for Tom as a basis for the discussion. If you're an expert in cybersecurity, maybe in the beginning you don't know the subject, you go to school, after 5-6 years you have some knowledge, that's the basic knowledge you have, and you go in the field and you start learning more and you're gathering experience. And at some point, maybe you are in a team and your teammates are going to help you in this matter. And eventually your organization or your security department is going to be so strong that you guys together are going to be able to address the issues and the needs. So when we're talking about an AI, it needs some learning. So it could be an initial learning, like you learn at school. Maybe you have 1 year of past data. Mm-hmm. This happens a lot. Like people come with some data and saying, hey, that's what happened. Logins are on our website. 1 year of logins on our website. And you can start with that. Or you can go in the field and start learning in the field, which is much harder. So I would not advise to start like that. This is possible, but I would really advise to start with a simpler problem. And then the real question is not when you start learning. The question is when you stop learning. And what's coming is that you never stop learning. Mm-hmm. And that's the whole idea is every day your AI should be able to learn and relearn and learn from like this new zero-day vulnerability that attacked your organization, or even more. Another zero-day vulnerability that applied to another organization. And by some techniques, you're going to be able to gather this knowledge and get maybe the actions to address these issues. And this is very technical and really real in the AI field. It's called federated learning.
Mm-hmm. Oh, yeah. It's almost like crowdsourced learning.
So, sort of. To go back on your actual question, where to start? You need to start with the data. At some point, you need some monitoring.
That's the dirty secret of machine learning.
Exactly.
Input.
So you do need to start with the data.
So that would be, to Tom's question, where does the AI initially learn? It's just like feeding it all kinds of data, right? I mean, that's how they learn. Is the models are created based on all the data that's input into the system.
So, for instance, if you want to do it yourself, you could just get an InfluxDB and start collecting data. For example, like your website connections, logins. Mm-hmm. who logged in, how many attempts. You start monitoring everything like that, and you get this data. And this would be the bare minimum to do it yourself. And then you need to build some models. So eventually, I mean, I've seen some people building their models themselves. If they have a strong IT department, they could. If you want to save time, you can use tools that help you do that, or use other people's experience.
Okay. All right. So he also says, how long does it take to learn? I guess that would be for the AI to learn things. I imagine a lot of that would have to be, well, it really depends on what you're asking it to do in the first place, right?
Yep. What you're asking it to do, how you format the data, how you present the data, what model you chose to use. Neural nets are data hungry and slow to train. Random forest, not as data hungry and fast to train. Is it as accurate? Who knows? Depends on the data. Very much so depends on the data.
So that's really where it's interesting to use tools. I mean, as a data scientist, I don't think you want to spend 6 months testing different models and realizing that, you want to use a random forest, but anytime you could realize that another model would apply better in this specific context, because maybe the first 6 months, you don't have much data, and a random forest is going to work really well compared to other options. And maybe just after 6 months, you have enough data, and your neural networks that didn't work before, with all this data, start to behave and work much better than another model. So that's why you not only have to implement models, you have to follow up the models. And that's why when you say there's a risk of taking the job of machine learning or cybersecurity people, I don't see it like that, because what I see is that the more cybersecurity AI things we develop, the more follow-up we need. The more we will see it works, the more implementations we're going to see. So it's really a positive circle that's starting.
Yeah, well, absolutely. Yeah.
As it should be, honestly.
Yeah. Well, we've gotten a couple more things in from the audience. Andre's actually asking a couple questions here. He said AI brings out expectations to cyber defenders, but of course, cyber attackers are going to use AI too. So where could AI make the difference to cyber defenders? He makes a very good point there.
Yeah, I'd be shocked if they're not already using it. Not going to. I'm pretty sure it's already out there in a thing.
Yeah.
I mean, they have communities of bad actors that work together. They have, businesses that do this stuff, just like, on the books, good corporations. It's the same thing on the other side. They're doing the same stuff we're doing. They're going after the holes, and they're using AI to find those holes. Honestly, for me, trying to absorb what can AI do for me is such a huge topic that any company that says, what can I apply AI to? It's the wrong question, in my opinion.
Throw a dart.
Yeah, I mean, literally everywhere and anywhere you could throw AI, and it's probably going to have 100-fold return on invest. But is that where you should probably put your money and your time and your effort? I don't know. Ask yourself, where's the biggest pain point for people that use what I build, or for me? Where am I spending most of my people time? And is it repetitive tasks that is effectively pattern recognition? That's probably where AI can fit. Answer a simple yes/no question. Start there. Don't try to build the world. Don't try to, build a castle when all you really need is an outhouse. I mean, you can be surprised how good a very surgical AI application to whatever it is you're working on can benefit your life. If it saves hundreds of man hours, you can imagine it's worth probably putting, several man hours into it to figure out how to build it. And you need data. If you're trying to build AI without data, it's never going to work. Unless, you're crazy and you do unsupervised and you're a genius. But most of us are normal people. We need data that's classified and labeled, whatever you wish to call it, that can be described. If you don't have that, you don't have machine learning. You need a problem that has data. That's a very easy problem to describe, to start.
So to your point, though, you could use AI or ML pretty much in anywhere in an organization. I think the issue that a lot of organizations are dealing with, and please correct me if I'm wrong, which I know you guys will, can AI, I'm assuming that AI and machine learning can actually help organizations understand where their security is currently maybe not as effective, and from there they can then maybe implement AI to help shore up that security or be more effective overall. Are we looking at security and AI, the use of AI and ML in security, not just for the actual defense, but also kind of an understanding of the networks and what they need to do?
For me anyway, my favorite thing is to see if somebody has already solved the dang problem before you build it yourself. Is it worth it to invest a whole bunch of time to build a tool that's already out there that you just got to buy? I mean, SIMs exist. The network monitoring exists, and that's kind of what they do for a living. So how are you possibly going to in-house build something that can absorb all those alerts with machine learning, which they use, properly and effectively in any reasonable amount of time when literally it exists? Just go buy it. Don't try to build it. If it exists, don't be silly. Take advantage of it. These companies aren't trying to gouge you with prices. They're trying to save you. They're trying to give you something that they spent a lot of time on. It's worth the money. That's for me anyway. Don't try to build something that solves all problems. And if it exists, buy it.
Well, myself, I have to say most of my customers actually tried by themselves to build stuff. And as Christopher said, building unsupervised machine learning is really a pain. It requires a lot of people, knowledge people, a lot of time. You could get some results. And I've seen people getting some results. And I think it's fine because there's a real lack of resources on this subject. So for me, it's fine that if people try themselves, they build some knowledge, and this is really fine. And what I've seen is that once they have some knowledge, they understand the complexity of the task, and maybe they don't want to spend all their time and a lot of resources on that, and start using what people have done for this specific context helps them a lot, and they can really understand why it's outsourced and them.
So with that, then, does it make sense to outsource these technologies then to help an organization? Because I'm hearing more and more about managed security services providers, and I know they've been around for a long time, but it seems like with the level of complexity that exists now in so many organizations, that understanding and being able to effectively secure what has become this layered approach to security and being able to do it effectively is almost a near impossible task for a lot of organizations. So does it then make sense that MSSPs help kind of fill in those gaps and hey, bonus if their technology is actually being able to utilize AI and ML to kind of pull it all together for that holistic end-to-end approach?
Yeah, so I think the biggest problem is if you're solving a problem that's already been solved, why? For me, if you're going to employ ML and machine learning and AI and all that business in your business, there really needs to be attacking a problem that hasn't been solved yet or that can't be solved yet, or perhaps whatever service you're talking about is just simply too much for them to be able to buy into, and that's fine. It has been democratized for the most part. I mean, accessing machine learning algorithms and being able to play with it and learn about it, it's just orders of magnitude easier today than it's ever been. I mean, you've got whole just toolkits that are free to do all of the old classical algorithms, plus the neural nets that you want to play with. If you want to pop it on a GPU, you can do it, and you don't have to pay for it. I mean, this is literally the time in the world to learn this stuff. You don't have to come up with these algorithms that they've already figured out what linear regression means, what logistic regression means. You don't need to know that. It's been democratized. You should you should learn it at some point, but you don't need to know the inner workings of all of this stuff. You just need to know how to use the tool. I have no idea how to build a car, but I can drive one.
Also, you can wonder, as an organization, you can ask the question, what is your core business?
Yeah.
So is it really to spend a lot of resources on subjects, very specific subjects like machine learning and on cybersecurity? If this is the case, it makes a lot of sense to hire a lot of people on this subject and really implement your own solution. If it's not, I think if you can have like 1 or 2% that really get the knowledge, that's very important, and then use the tools. And I see Tom is asking questions about smaller businesses. I mean, I can understand smaller businesses cannot go into AI, but themselves. But I got many businesses that are my customers. They don't know anything about AI, but they're getting a lot of value out of it, just using the right tools. So not everyone has to learn AI. Not everyone has to learn cybersecurity. You have to understand your positioning and take the right tools.
So we have another question here from Tan, who asks, the difficult part of the deep learning is the amount of data. This kind of goes back to a conversation we were previously having. Is how clean is the data set? So the cost is high due to time on annotation. Is there a shortcut on modeling with deep learning?
Wouldn't that be nice? That's why it's the dirty secret.
So we are trying to help.
Depends. Yeah.
Yeah, we are trying to help on a very specific subject, which is labeling. So definitely, as I said, unsupervised learning is really hard. And what you really want to do is classification, but in fact, you cannot because you don't have a balanced data set of attacks and non-attacks. In this field, it really doesn't make any sense. So what we're trying to do is to multiply labels. The idea is to help users get more labels, so be able to really identify the pattern of an attack, and then use machine learning techniques to increase these labels in order to have a magnitude of labels that is actually usable. I don't think it goes to the point where you do the actual classification, but in machine learning, having some labels helps a lot.
Okay. All right. Got another quite kind of interesting food for thought question. Manicam, I think it is, asked if it would be a good starting point if we extend our SIEM SOAR to build some inference and predictive models. Can you take existing technology and kind of build on that to insert a level of AI that perhaps your organization doesn't really have right now?
Yeah, that's exactly what you should be doing. That's the tool. That's the hammer. How do you take this one thing that spits out millions of alerts a day or however many come through a SIM and classify those or figure out what's important and what's not? There's got to be a way to capture what I spent my time on as a human being and have the machine learn from that pattern and behavior. And unless I miss my guess, most of those products are likely looking into something just like that, or at least plugging some holes where people spend a lot of time, just like we did, just like Julian here is doing. It's where you need to spend your time. It's not, I want to be able to solve all the world's problems with a push of a button. That's never going to happen. We don't have Skynet. It's just not there. They can't think creatively like we can yet. They can do pattern recognition. They can group things together that look similar-ish. That's what they're good at. It's a totally different way of programming. You kind of got to flip it on its head a little bit and solve a simple problem first. If you're new to machine learning and you try to do something like predictive modeling and inferences for SEM-SOAR, you're gonna beat your head against the wall because it's a very complex problem, and you have to describe the data and you have to label the data. If you have a whole bunch of labeled data already, I don't know what that labeled data might be an example of in the world out there, but for us, it was security information, a whole bunch of sources, a whole bunch of sinks. Can we feed that into the machine and have it guess which one's supposed to be a source in the sink? It's already labeled. Yeah, of course we can. Super easy. So there's almost certainly areas in almost every product that's out there today that we can go after. We can attack with those simple yes, no questions. Am I interesting? Am I not interesting? Should I care? Should I not care? Is this a noun? Is this a verb? Is this a pronoun? So on and so forth. There's a variety of different questions we can ask the data, and that's really just keep it simple. Stop. Don't try to solve the world's problems, especially if you're new. If you're a genius and you're building Skynet, well, then you go do you, and you can build the solve the world's problems machine, and that's great. But for us mere mortals, we have to solve simple problems, and maybe it's 15 simple problems you ask in a row, and of those 15, if I answer yes here, I go to this set of models, and if I answer no here, I go to this set of models. It doesn't have to be one and you're done. It could be
Mhm.
15, it could be 500 models. In one of our cases, we have over 700 models that ask the questions. Am I this or am I this? Am I this or am I this? And it goes different branches based on those answers. So it doesn't have to be simple, but it doesn't have to be complex.
All right.
Yeah, I really think, I quite agree with Christopher on this. You have to start with the data and start building on this, and probably build simple or understand the most important problem you want to achieve, to address. See if there are solutions on the market that can help you. There are free products, there are products you have to pay for. All options are available. So try to build on this progressively and not solve all the problems. Really start with your data and come up and up slowly to the point you want.
It's almost every person that talks about machine learning and has no experience with it is just like, what can I do with it? It's like, well,
Yeah.
you want to do with it. What do you
Right.
want to solve it?
Right.
And user everything is like, no. Focus. Small.
Yeah, that's very important. I think if you're starting with machine learning, is you have to address a problem. It's very hard to just get data. There is this idea coming from the data mining world where people think you can just throw a bunch of data and say, oh, let's see what's interesting in it. Data is gold. Where is the gold? And what we see in machine learning is that we have to address a problem. It's about like optimization in math. We're trying to optimize something, improve something, identify something.
That makes a lot of sense. That makes a whole lot of sense. And that goes back to what I was saying earlier about being able to kind of identify where your problems exist with your current cybersecurity setup, and being able to have the AI and the machine learning to really kind of hyper focus, if you will, on those problems. Rob just put in a comment, getting to the place where we can correlate incoming threats and attacks in a SIEM with low-code vulnerabilities in such a way that it can be incorporated quickly into a development pipeline would be a great step forward.
That wouldn't be a great step. That would be the end game.
Right. Well,
that's the perfect thing.
I think Rob is preaching to the choir here. It's definitely something that I think we're all kind of hoping to achieve at some point. But it actually kind of brings up an interesting conversation, which is, when we're looking at incorporating AI in cybersecurity, is there a place for it in the DevSecOps pipeline? Because
literally everywhere.
Yeah, we did establish that, but it's like we talk about DevSecOps, and DevSecOps is a difficult thing that a lot of organizations are grappling with. Does AI actually kind of make it easier for them, or does it kind of add yet another level of complexity that right now they just can't handle?
Yeah, for me, it's the same question as everywhere. What problem are we trying to solve? Where are we going to get the data from? Can we answer the question as people? If we can't answer those three questions, then AI is not applicable to whatever problem we're talking about. So we could be saying, can I make my bill go faster? Can AI help with that? Probably, maybe, who knows?
Yeah.
But that's not the right question to ask. We really need to figure out where we're going to focus, because we don't have, the super intelligent Skynet level. I can teach it anything, gave it all the encyclopedias in the world and it knows everything about everything now. And I can ask it anything. We don't have that yet. We don't have the multi-vac if you're an Asimov fan. It doesn't exist yet. It will possibly, in our lifetime, we'll see. Depends on quantum computing and where that sucker goes. But for right now, we have what we have. And they're really, it's like asking hammer, can you, hammer in a screw? It can't. You need to use the tool for what it's designed to do. And if there is a gap, that's where you identify the gaps. You look to make sure you have data. That's the number one problem with machine learning. It's not building the model. It's not figuring out the features. It's not even figuring out how long it might take to build, or how to persist the model, or how to update the model, or federate it, or any of that business. It's the data. It's all the data. It's always the data.
So go ahead.
Yeah, just to be a little specific, there's a use case I see more and more coming from actual users, which is about the testing phase. So it's a very expensive phase, and it's not only about security, it's about many other subjects. It's about robustness of the solution. It's about the image of the company, it's about many things, but it's also about security. You want the most stable solution. And what I see coming from customers is version updates, because when you're building a new solution, usually the testing phase is really huge. But when you're doing like a dev cycle where you update your version every day or every week, then there is an opportunity for bugs to come in and to be the ground for cyber attacks, vulnerabilities. So I've really seen recently this will to learn how the solution was working or behaving in terms of networking, in terms of memory consumption, and try to use that as a basis for machine learning and detect new behaviors, which is not definitely possible attacks, but at least that's, instead of having tons and tons of data and try to find anything in that, you just get very specific things to look at. This new version has these 10 new behaviors. Now, let's take a look at it. Christopher talked about actionability. I think that's really important, because you don't only want to know that things happen, you want events, specific events, and you want to know what to do in this case.
Yeah, absolutely. And we talk about AI in the DevOps tool chain quite often over on DevOps.com. So, to me, it seems like, just another tool in the toolbox for organizations. But the trick is understanding how to use it and how to use it most effectively. So, guys, it's amazing. We have 9 minutes left to the top of the hour, and so I can't believe how quickly this conversation has gone. But I do want to just kind of maybe put on our fortune teller turbans and look into our crystal ball a little bit about, where do we see AI and machine learning in cybersecurity? And I know this is a very broad question, and again, it could go in any number of directions. But do you think that we're ever going to get to a point where, excuse me, cybersecurity is handled entirely by the machines, by the programs, by the data, to the point where we won't even have to worry about it? We'll just kind of, do that thing that everybody strives for, which is just plug it in, turn it on, and let it go do its thing? Or do you think we're always going to need to have human involvement with cybersecurity?
I personally think for the foreseeable future, we'll always need people. Always need people. I mean, our brains are what, 10 to the 42nd in terms of processing power? Computers are a long way off from that. So until they catch up to us, we're just smarter than they are at the moment. Sure, they're fast. Sure, they can do a bunch of repetitive stuff over and over and over again. But can they look over here and say, well, that doesn't seem right, unless they've been taught it? We can put that stuff together, and there's always going to be a need for people. Although, having said that, if I had my way, we would replace the jobs we have today with the jobs that make more sense tomorrow. Instead of, I need to review findings to see which ones are interesting in my space, it's, I need to teach my developers how to fix this stuff, to now I just need to make sure that the validators and sanitizers we wrote are correct. It's a progression to where we get to the actual good stuff as the experts, instead of wasting experts' time effectively checking meters. We don't want them doing that. We want them making sure people's homes don't explode. We don't want to waste our time with the mundane. We want to be interested and interesting with the stuff that we look at. And that I think we can do.
Yeah, I mean, I don't know for the future, but right now we are so far from getting where we could go. I mean, in AI, we don't really have explainability. So we could detect issues, but we don't really know why we detected them, depending on the case, for sure. That's a big issue in cybersecurity. I mean, we do need trust, auditability, and we don't really have that now. So it's going to take years to get this research field get a solid answer. As we said, unsupervised learning, which is very important in this context, is very small right now. It's really young. So we're really not there right now. And you have to see that attacks are going to increase in terms of creativity. And AI is going to help attackers, in fact. So I don't see an end in this. And we need people to manage that.
Yeah, so it's not the be all end all to all of our issues in cybersecurity,
There is no
which
silver bullet.
yeah. Oh well, darn it. I thought
Yeah, we wish there
thought
was,
we
but
had
there
something.
isn't.
So all right, so just to kind of wrap things up, I mean, we've talked about the fact that AI and ML can help solve that cybersecurity or at least fill in cybersecurity skills and people gap, and some of the ways that organizations can use AI or ML. But is there anything that we've not discussed regarding AI and ML that you guys think we really, really should at least touch upon in the last few minutes of this webinar? Christopher, I'm going to start with you, and then Julian, and then we'll wrap things up.
Yeah, I mean, we've touched upon it. I just want to leave folks with the knowledge that you can't solve the world with machine learning yet. But what you can do is get rid of the mundane, boring stuff. So if you can focus on something you have data for, that you have a question about, that's where you should be putting your time, effort, and energy to putting machine learning in your world, whether it be for security, whether it be for pipeline, whether it be for DevOps, whether it be for attacks or SIMs or whatever you want to call it. Wherever you spend your time and you have data and people are doing the mundane, repetitive tasks, that's where machine learning belongs in your world. Not can you please just solve all my problems? I'm going to push a button, go get some coffee, and enjoy Netflix. No. We actually still have to work.
Yeah, I think the journey is a really long journey, and you really have to start. So where you start, where you have data, and try to do something, and you're going to see there are tools available, there are experts, there are resources available on the web, and you have to start somewhere and then take your decisions about whether you work on it yourself or try to find people to help you, find resources to help you, and go on. The more people in this field, the better it will be, and the safer the world will be.
And I guess if I could say anything about it, it's the fact that we can't do this without AI and ML. And so at some point, an organization is going to need to adopt some level in their organizations because the problem and the complexity of IT environments has grown too large for mere mortals to address on their own. So I think it's fascinating technology. I think it's early days, and I think there's a lot of promise in it. But I think a lot of it has to do with understanding exactly what your problem is before you go about trying to implement it. And it's not a cure-all for everything, but it's certainly a very good place to start. So
it's a heck of a band-aid.
yeah. So. All right. So with that, we are 3 minutes to the top of the hour. And I do want to remind the audience that today's event has been recorded. So if you missed any or all of the conversation today, there were some good points that were really brought out. So highly encourage you to do it. If you missed any or all of it, or if you just want to listen to it again, you'll have the opportunity to do so. We are going to be sending out an email after today's webinar that contains a link to access the webinar on demand. And the webinar is also going to be living on the Security Boulevard website, so you can go look for it there. Just go to securityboulevard.com/webinars and look in the on-demand section. It should be right there waiting for you. All right, I also mentioned at the top of the hour that we would be doing a drawing for $25 Amazon gift card. So real quick, let's go ahead and do that. Our first winner today is Stanley K. Congratulations, Stanley. Then our second winner is Jim R. Congratulations, Jim. Third winner today is Richard F. Congratulations, Richard. And our fourth and final winner today is Tom T. Congratulations, Tom. We'll be following up with all four of you offline via email to get your Amazon gift card over to you. So please check your inbox. And if you don't see it there, please check your spam folder. Julian, Christopher, what a great conversation. I really, really enjoyed the hour together. And I hope you guys enjoyed the conversation as much as I did.
Oh, yeah. That was awesome.
Sure.
All right. Great. Well, I'm sure we'll have future conversations about this very topic. And I also want to thank the audience for joining me today. Such great comments, such great questions. Love the level of interactivity, and I invite you all back for more webinars to come. We've got a lot of great ones coming up on Security Boulevard and DevOps.com. So check out the schedule. But for now, this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.